here at Scholars Scat TV. Let us continue from where we stop. We're still talking about that's part, let's say the part 2 of measurement of heat energy. We just previously talked about the first part of it. But this time around, let us go to different method of measuring heat, specific heat capacity of a substance. Now, we have the electrical method of measuring heat capacity of solid, specific capacity of solid. We also have the method of mixture. But today, let us talk about measurement of specific capacity of a solid by the electrical method. Measurement of specific capacity by the electrical method. Are you getting it? Now, it's very simple. Now, you have to look at it now. You draw, for example, you have a bowl, a aluminum bowl, or a solid metallic bowl, and you pour water inside. Now, you decide to heat the water, raise the temperature of the liquid such as water. You need an electrical supply, which can use a boiling ring or any other thing. Now, you draw the material, look at it experimentally. You can draw a bowl like this. Now, this is a bowl, a metallic bowl. Are you getting now? You put a source of electricity. Are you getting, for example, like your boiling ring? Place your boiling ring inside. Boiling ring inside. Make sure you touch the bowl. This is the boiling ring. Now you connect. Normally the boiling ring has a wire. Now you plug the wire. Let's see, pass the wire to any electrical source. Any electrical source. Right. This is the electrical source. Now I also have a thermometer, which is used to measure temperature. You plug in a thermometer. This is a thermometer. Call this one thermometer. Heater. Bowl. Metallic bowl. Look at the diagram here. Are you getting it? Good. We have a thermometer which is to measure temperature. The source of electricity, which is the boiling ring or heater. Now this is the metallic bowl. Now let us measure the temperature of this solid, or a specific capacity of this solid. Remember, the quantity of heat required to raise the temperature of a unit mass by 1 degree Celsius or 1 Kelvin. Now here we have you measure the mass of the solid metallic bowl in a weighing balance. You get a weighing balance, a beam balance. Normally we use beam balance or chemical balance to measure mass of a substance. So first of all, you measure the mass of the metallic bowl in a weighing balance. Are you getting it? So you record the mass as M. Are you getting it in kilogram? As M in kilogram. After you measure the mass, now you carry your electric source or your electric heater. You put it inside the bowl. Make sure you touch the metal. Are you getting it? Then better. Also insert the thermometer inside. Insert the thermometer inside the bowl. Are you with me? When you insert the thermometer inside the bowl, you can now switch on your electricity. Are you getting it? Switch on your electricity. When you now look at the temperature, see that the thermometer will begin to rise, to read. It takes the reading of the thermometer, which is the temperature now. You now take temperature, which is temperature. Theta stands for temperature. You measure in Kelvin. In Kelvin, abbreviation K. Are you getting it? Good. Now, there is electrical heat energy. Before then, you also know the specific heat capacity of the bowl. The specific heat capacity of the bowl, which is C. Specific heat capacity of the bowl, joules per kilogram per Kelvin. Specific capacity of the bowl. Are you with me? Now, this is the heat energy of the bowl. Specific energy of the bowl. Now, you see that there is electrical supply on this. Are you getting now? Electrical work done or electrical supply on the metallic bowl will now be, as we have done in our previous classes, in our SS1 class, we now say electrical work done, H here, or electrical energy equals to IVT, where I is the current supply, current flowing through the bowl, and also the voltage, which is the potential difference flowing inside the bowl, and also the time, the time taken. Are you getting it? Like this H equals to IVT, given as the electrical energy supplied to the bowl. Are you getting it? Therefore, we now say the electrical energy supplied to the bowl is equal to the heat energy of the bowl. Heat energy of the bowl. So mathematically, we can say IVT, which is the electrical energy supplied to the bowl, will be equals to the mass times the specific capacity times change in temperature of the bowl. Are you getting it? Good. Now remember, we are talking about measurement of specific capacity on solid. Now we can by the electrical method, we can now make specific capacity the subject of the formula by dividing both sides by the coefficient of MC, which is specific capacity. When we do that, we now have that IVT all over M theta equals to MC theta all over M theta. So here you have two things that are common here. Are you getting it? So we cancel the M is common. Do it mathematically, M will cancel M. And temp theta will cancel theta. Therefore, we can say that specific capacity of solid will now be IV, the electrical energy supplied all over the mass of the bowl times the temperature of the bowl. So this is the method of measurement of specific capacity of a solid by the electrical method. Where I stand for current, V stand for volt, the potential difference, and T stand for time. And don't forget, M stand for mass here, and this theta stand for temperature of the material. You get that? This is the method of solid, of very specific capacity of a solid by the electrical method. Don't forget again, I like repeating myself. This IVT is electrical energy supply to the bowl. Are you getting it? To the bowl. Why this mass times temperature is given to you from the bowl, the mass of the bowl and the temperature of the bowl. Are you getting it? Now, our next class will be talking about measurement of heat energy of a liquid by the electrical method. Thank you. Don't forget to like, share, and subscribe on our YouTube channel at Scholars Card.